Good afternoon, good morning, wherever you are tuning in from today. And my name is AJ Piskor. I am the Director of Combustion Products for Westman Instrument Company, part of Kelly Industrial Automation. And with me today is Brian Harris. He's the Combustion Solutions Manager for AC Technical Services, who is also a Kelly company and part of the Kelly Industrial Automation Group. Brian has been in combustion for basically his entire career with AC Controls and AC Technical Services, had various positions over the last 25 years. And today's topic, we are going to be talking about why should I tune my boiler or process burner. Brian will spend about 30 minutes going over different aspects and reasons and tricks and tips on what to look for or know when to bring somebody in to look at your boiler or process burner. This is an interactive webinar for those of you that are attending live. If you do have any questions, you can enter your questions into the chat or to the questions menu that's on the side. I will go through and address those all at the end. And again, appreciate everybody taking the time today to join us, and I'll turn it over to Brian.
All right, well, thanks, AJ. So as AJ said, Brian Harris, have been with AC Controls, AC Technical for pretty much my entire career. And we do a lot in the combustion world on the project side, and then also the part side. So today we're gonna go through some of the benefits of keeping your boilers maintained, tuning your boilers, and your process burners. So a lot of times I might just say boiler, but this also really kind of leads into your process burners as well. A lot of times with a boiler, it's we find it's easier to show immediate before and after documentation. So it's in some of the examples we'll give later, we'll kind of bear that out. So today we're just going to talk about the benefits of your tunings, how frequently you should do it, and then we're going to give some real world examples of how much money you can actually save by doing regular tunings. So, sorry, so benefits. So the one big benefit of keeping your burners larger, process burners, your boilers, keeping them actually tuned regularly is reduced emissions. So I know people could be joining from all over the country. We have different air permitting requirements based on where we live. I'm based out of the Southeast in Charlotte, North Carolina. Our air permitting is not as stringent as some other places, but that is still, no matter where you live, that's should be on everybody's mind, is keeping your emissions down. So as we check for this complete combustion, make sure we have correct fuel air ratio regularly on this equipment, then we can also help reduce emissions with that. One of the next big things, and this is many times what helps pay for these service, pay for the guys to actually come out, do your routine inspections, do your routine boiler tunings, process burner tunings. It's one of the biggest benefits is improved efficiency. So in just a little bit, we're going to show some real world examples of how much money that can really save. So in that process, and in the tuning process, what we're doing is we are making sure that we have the correct fuel to air ratio for whatever burner, whatever fuel we're actually running. And one of the things that is that kind of goes along with this is that we're really talking about mid-size, larger packaged equipment in manufacturing plants, maybe hospitals, universities, but just regular maintenance, regular tunings. It even it can affect yourself at your house and your personal equipment, keeping your furnace tuned up at home. You can improve efficiencies, your vehicles, your yard equipment, whatever. It's just a good idea to keep these things have regular tunings. So another large part is improved safeties. So when a boiler or burner technician comes in to go through and check the boiler, tune the boiler, many times we're also looking over the safeties. So a large part of that is the combustion safety side of things, and that's just making sure that we don't have dangerous operating conditions. We're not a fuel rich. We're not putting too much fuel into the burner, either on a boiler or a process burner, to cause overheating, overpressurization. And then the last thing is cost savings. That really goes back to the your improved efficiencies, and that just helps with no matter what kind of fuel it is. That just really helps with the reducing fuel consumption, and that ends up with a reduction in operating cost. So this is a typical answer in this world, as we would recommend, especially on your larger boilers, larger process heat burners, is having them tuned, or at least checked, to make sure they're still in tune twice a year. And that's typically done in the spring and in the fall. And the main reason for that is because of temperature changes. And what happens is the temperatures change outside, the air densities change, and that can greatly affect the fuel to air ratio. So a lot of times, and depending on where this equipment is, it could be located outside, and that has a great effect when we have temperature swings, air density. As the air gets colder, the air is much more dense, so it's putting more oxygen into your equipment, and that can throw your fuel air ratio way off, end up with excess air, which then leads to much lower efficiencies. We just talked about what can actually affect your boiler or your burner combustion. The environment, like we just talked about, atmospheric changes, that's one of the largest things. But then another thing that is happening, especially where we live in the Southeast, construction. There are plant expansions, there's building going on everywhere. And what we end up seeing is, our techs might be in 1 year, and then they might come back in 6 months later or a year later and find out that they've added, one of our customers might have added additional equipment, either inside the building or beside a boiler that's outside. And that can really affect the airflow. And based on the airflow, that is where we get the air for your combustion air that's entering and mixing with the fuel to burn and produce steam or hot water. And that's one of the things that a seasoned tech, when they come in, that's one of the things that they would actually look for. So another thing is just while a boiler tech is in, they're going to look over the boiler, inspect for the wear and tear on the components. Depending on the style boiler, we're going to talk a little bit about some of the different style boilers out there, or the process burner. It could be, there could be a lot of mechanical linkage, and just over time, that mechanical linkage can wear out. Even with larger boilers that have actual control valves, those, the mechanical equipment just does wear out over time. And that can really affect your fuel air ratios, which can affect greatly your boiler efficiencies. So as we talk through the different boilers, don't really know the people that are on the call and how much experience you have working out in a plant, or just even if you don't work out in a plant, walking by a piece of equipment and just understanding what it actually is. So we're going to talk a little bit about a couple different style boilers, the most common style that's out there, some of your process burners, what kind of applications they could be in. And the first one is just a standard fire tube boiler. This example is a Cleaver Brooks boiler. They're one of the larger manufacturers in the country. These are very common in industrial manufacturing plants, hospitals, universities. They're typically used for lower pressure steam in an application where you need, up to maybe 150 pounds, up to 200 pounds total of steam pressure for whatever it is your plant, the requirements of your steam load. And they are typically sized in horsepower, which is a process guy, and looking at it, it's, you see a horsepower number for a boiler, and a boiler is producing steam or hot water. So one of the quick and easy conversions for if you have a fire tube boiler that's sitting there is you can multiply the boiler horsepower times 34.5 to convert that into pounds of steam per hour. And that kind of helps with that. What we end up with, it kind of helps with knowing what the steam flow of that actual boiler is. The next style boiler is a water tube boiler. These can be found in a lot of the same locations, manufacturing plants. Typically, these are used when you need maybe a higher pressure or more capacity at your plant. And these boilers, a typical packaged water tube boiler would be in the 30,000 pounds of steam per hour to maybe 100,000 pounds. There are plenty of packaged 150,000 pound boilers. And these are typically used in an application where you would need maybe a little bit higher pressure or more capacity. And that would be, 100 to 500 pounds. And this is kind of the world that we is over on the AC technical services side. This is where we work a lot in, is the larger packaged boilers on the controls end. And then a lot of these larger water tube boilers at hospitals, universities, larger places that need multiple boilers with larger distribution loops. They might be heating multiple buildings. And then the last one is kind of what we're talking about with the process burners. Now, so process burners can be, when you say process burner, they are from, small little 500,000 BTU, million BTU burners that are just heating air. They might be used on a makeup air unit on top of your building, and it might be a 5 million BTU burner that's just helping to heat the building. Most of those would be natural gas. But then also, we do a lot on the process heating, heat treat applications. And so these would be used for metal heat treating, ceramics, multiple different applications out there. And most of these are natural gas fired. You do see some electric, but most of these are natural gas fired. And we can get into some of these when you get into larger kiln, rotary kiln style at maybe a paper mill, or you can get into, 100 million, 200 million, 250 million BTUs an hour, which is, they get into some really big burners, really large users of fuel. So one of the things, the next part we're going to talk about is just getting an idea on how the excess air and the oxygen content in your stack, how that correlates. And then we're going to talk through just a real world example, a couple real world examples of how this can actually save you some money. So when we talk about excess air, that is basically extra air that is leaving in the exhaust that is not really needed for a stoichiometric ratio of fuel to air. So typically when we're talking about natural gas, that's a 10-to-1 ratio. That's 10% oxygen, 1% fuel, or 10 parts oxygen, one part fuel. So as we talk about an excess air or the oxygen content in the stack, they are directly connected. They are related. So in the examples we're going to use, we can look at this and get an idea, a real idea on efficiencies just with a boiler using a stat gas analyzer. And that's typically how we do a tuning on a boiler itself. So we would have a piece of equipment that measures O2, CO typically, and then a lot of times other emissions, which would maybe be CO2, NOx, and some other things, SO2. But for a lot of the tuning and for the efficiency side of things, we're really looking at that oxygen number. So when we actually do a stat gas analysis, we would do it throughout the firing rate of that boiler. And as we do that, we're checking the fuel to air ratio from your low fire, which would be the minimum flame, the minimum production of steam, up to high fire, which would be the max output of that boiler. And so typically we start with a little higher oxygen content, and that is mainly so that you can have a good stable flame. And then as we ramp up the firing rate on that boiler, we typically drop the oxygen content. And most of the even older burners, but even a lot of the newer burners are made for that. They operate much better as we do that. We start dropping that excess air, so we also drop the oxygen content in the stack. So what we're going to talk about is these are some real world examples. So this is these are some numbers that I pulled together, and it's basically a 600 horsepower fire tube boiler, which is a medium size, pretty average out there. Ran some numbers with this, and this is just a single boiler. So we look at some of the operating parameters of the operating parameters, and this would just be a maybe 125-pound boiler. If we look at the stack temperatures, a 450-degree stack temperature, which is a pretty average number for a lot of these boilers that we look at. We look at boiler excess air, and this is a kind of an as found example of something typical that one of our techs would walk into. As he's getting ready to do a tuning, he would, check and document all the as found numbers beforehand. And this would be very, very typical. And we kind of base these calculations on just a 50% average load of the boiler. It's running about 50 weeks a year, and it's running about 16 hours a day. And that's just kind of a good average numbers for a process boiler like this in a manufacturing plant. So if we look at this, the fuel numbers are based on the industrial fuel prices. I think I plugged in $8 per million BTUs. That was a couple months ago, and that was based kind of in the Midwest. It's a good average. In the Southeast, our numbers are a little bit lower here. I think we're averaging around $6 per million BTUs. But if we look at this with some very conservative numbers, that smaller fire tube boiler, just in fuel production or fuel usage, it cost about $493,000 a year. And that's just based on those numbers of 45% excess air, which is about 7% oxygen. So it's a good bit of money to run that smaller, medium size fire tube boiler. So if we look at most the applications of this would be, we might have 3 of these in a single plant. You might only run 2 of them at very similar loads to this, but maybe $1 million or so a year just in a smaller, medium sized boiler plant. So if I take, these would be kind of maybe the as left numbers. After a tech comes in to do a boiler tuning for you, and if we're able to get the excess air down to about 15%, which would be roughly 3% oxygen content. And this would be very standard for how we would leave a boiler. And it would typically be in that 3% oxygen content range from 30-40% firing rate up to your maximum fuel usage at high fire, so 100% firing rate. And if we look at that, just on that one medium-sized, very conservative number boiler, that's a cost savings, a potential cost savings of over $10,000 a year for that one boiler. So what we find in this is that you're keeping up with your regular tunings. It can easily pay for itself. And you have a boiler tech on site that's a couple $1,000s a day basically to have someone out there to do the tuning. They can typically do a boiler in a day. So it makes a lot of sense to have this and keep that tuning program up. So the next example is this would be typically maybe a larger water tube boiler. The example that I put in here would be 2,500 horsepower, which is, if it converts over, this calculator, 2,500 is the largest I could use for horsepower. But that would convert over to about 85,000 pounds of steam per hour. And that would be a good size, medium to larger water tube boiler. And that's a lot of the boilers that we actually work on, do controls on. That would be a good size for those. We see these a lot in our local universities throughout North and South Carolina because they have large distribution loops and they are supplying steam to multiple buildings for heat primarily, but then also a lot of the other, some of the laundries use steam, even a lot of the labs use steam for conditioning spaces. But so this would be about an 85,000 pound an hour boiler. If we look at it, I use pretty much the exact same numbers as far as average load. Just say 50% average load. It's going to operate 16 hours a day and roughly 50 weeks a year. You typically have a week or two shut down for these boilers just for maintenance. And in this example I used, it's going to operate 6 days a week. So if we look at this, it's a big number. So just that boiler, medium, larger size water tube boiler, estimated fuel cost is over $2 million a year for that single boiler. So if we think about using the same numbers from the fire tube boiler that we were looking at, and actually being able to tune. So if we look at walking in and you have a stat gas analysis and we're looking at around 7% oxygen content or 45% excess air, we're able, excuse me, we're able to drop that down in the 15% excess air, which is in the 3% O2 range. And like I said before, that would be from around 30%, 40% firing rate throughout the max range of that boiler. That could potentially save $43,000 a year just in fuel costs. You also look at, even below on this calculator, it shows estimated yearly CO2 emissions. Those are some pretty big numbers, especially when you're looking at your emission savings. Any kind of credits, green credits that are out there, it's a pretty big number. But just being able to, with a day's tuning for a natural gas fired boiler, to be able to see those that kind of savings within a year, that's a pretty big thing. So I think that's all I really have on the tuning portion of it. AJ, do we have any questions?
Yeah, we have a question from Jason. He asked that we have a boiler outside, but under a cover to protect it from the elements except for one side. What can be done to further protect it, but allow it to operate properly without limiting airflow? Jason is still attending, so you can, if you've got a follow-up question, he can either unmute himself or write in the chat.
Yeah, it's difficult. Typically, what you would see, we see these boilers like this all the time, and about the only thing really is just to finish out a building around it. Anytime you have a boiler in a building, you have to think about um, we need a lot of air for the combustion air. So typically, I, I I think on the engineering side, it's a 4-to-1 ratio. You want to have 4 times the air available that then would be actually needed for the boiler. So what we'll end up seeing many times is, you might have a metal shed sitting outside, boiler might be stuck in it, and we might just go ahead, the company might just go ahead and close it off around it, but we want to make sure that we do have either outside air dampers. Typically, that's all you would need is just open air dampers to make sure that we can get all the air that's needed for that combustion air. In a case like this, it's kind of worst case when we talk about the seasonal changes for air, because it's really outside. It's going to be pulling direct outside air in. So depending on where that boiler is located in the country, you can have drastic changes, even just during the day. But seasonal changes with those air densities and your combustion fuel air ratios can really be all over the place.
All right, thank you, Brian. All right, don't see any other questions.
All right.
So we wanted to let you know that we have we are a distributor of Testo emissions analyzers. And actually, wait, Jason does have one more question before we jump into this. What is the average life of a boiler?
A lot of that is based on maintenance programs. So one thing that greatly affects, there's 2 main things that really affect the life of a boiler. Water treatment, water treatment, water treatment is one of the largest ones. So you need to have good clean water, good soft water. That's what your deaerator tanks are for, is to get the oxygen as much as possible out of the water. And then water softeners really help with that scale buildup on the inside. So water treatment is probably the #1 thing. And then on the combustion side, tuning, just to make sure that you're not, depending on the style of the boiler, you're not sooting up the inside. Um, what ends up happening with bad water treatment is on just say a water tube boiler, you end up building scale up on the inside of the tubes, and that decreases efficiencies. And so what ends up happening is you have to put more and more and more heat to get that heat transfer to produce hot water or produce steam. And fire tube boilers are very similar. They just build up on the outside of the tubes, they build up scale. And then on the tuning side of things, we are firing fuel and air into an open chamber. And on a water tube boiler, we can build up soot. If we don't have a proper combustion, we build up soot on those tubes, and that also acts as an insulator. So the biggest thing would be water treatment and then continuing tuning. But I've seen boilers fail within a year with bad water treatment. Large, very, very expensive boilers fail with bad water treatment programs. We have customers now that have boilers from the 1920s that are still up and operational. And that's on a couple of our university campuses. We have a coal-fired boiler from 1923 that was converted to natural gas and fuel oil in the 70s. And it is still up and operational. It's typically is a backup boiler now, but we tune the boiler every single year to make sure that the boiler is up and operational and ready to go.
All right, I got as much of that as I could
Okay.
into the chat or into the questions tab. But so thank you, Brian, for that great explanation. I'll give you guys a little bit of time if you have any other questions to type in, but while we do that, I did want to let you know about this limited time offer that we have through our vendor partner Testo. They've got a number of different analyzers, and maybe some of you guys that have done boiler tuning are familiar with the 340 or the 350. These are portable analyzers. They're fantastic analyzers, and you can get a free sensor upgrade when you order from now through the end of the year. And we do want to let you guys know, since I don't know exactly where everybody is calling from, that we are territory limited as far as where we are able to sell the Testo products. But you can reach out to us and we can let you know if we're able to sell to you or not. I would think though that if we're not your local Testo distributor, that you should be able to go to your local Testo distributor and enjoy the same promotion. I don't see any other questions, so I think we'll gavel this. Oh wait, and just as I say that, Jason comes through with another one. All right, does an electric boiler require tuning? We have been getting a push to possibly go the electric boiler route. So that's a great question.
It does not really. We have a couple customers that in the past had electric boilers. I cannot think of anyone. I cannot think of anyone right now that has one that's in operation. But there is no real there would not be any combustion tuning because it is just it's a big, huge water heater or a big electric heater. It's probably as much or more reliant on good, clean water. The electric boilers are typically very fast to heat up and cool down. So water treatment would be a huge, huge priority with an electric boiler. They're also on the larger scale, it is a massive, massive amount of electricity. We had a hospital probably 15 years ago that put one in, and it required a separate substation just for the electric boiler.
Okay. All right. Jason, do you have another one, or does anybody else on the call have any other questions for Brian or I? I will let you know, of course, that on this screen, you'll see my contact information as well as Brian's contact information. Definitely would recommend, saving the email addresses. We are frequently checking those and happy to help you guys out. And again, if you need to give us a call, our phone numbers are there as well. Again, Brian, thank you very much for the presentation. I thought it was very informative, and I hope the attendees felt the same way. A recording of this presentation will be available on lessman.com. If you click on the training center, give it a couple of days. So if you've got colleagues that you think that may find this of interest, you can go through and forward them the link to that training center, as well as a number of other recordings that we have done in the past. I've done a number of them myself as it relates to troubleshooting that you guys may find of interest, and we also have a number of other not only combustion topics, but topics relating to a lot of the other products that we carry. So again, thank you guys for your time. Please be safe. Please let us know if we can help you out with any of your combustion or burner tuning needs. We are here to help.
Yep, thanks a lot, AJ.
All right, thank you, Brian.